All right. Let's do this. Um, so, let me take off my shoes, get comfortable here. Just went for a walk. Got some food. Feel a little bit recharged. Feel like I have a little bit more energy to do some more stuff here. What we need to do next is just see if we can get this voxel ray marching to work, right? And we're just going to try to ray march into the voxel, and we're just going to stop once we hit a non-empty voxel, right? A full voxel. Once we hit a full voxel, we'll be like, oh, we're done here, and then we'll stop, right? So for us to, be able to do that, we need to, well, first, let's take this code that we've been working on, and we're going to paste it back into the editor, make sure that the code that I have in my editor matches the code that we're working with, and it does. So, the first thing we need to do is we need to remove this dolly. So, the dolly effect we're doing, I know it doesn't look like a dolly, but that is a dolly, because we're slicing through the coordinate space with the orthographic perspective, and that's just the way the dolly works. So I'm going to put a 0 for the dolly, and now if we run this again, we should just have like this static kind of scene with a little bit of green right there. Okay, so now, in our actual ray marching code, so from here we have the frag color is from the render scene here. So in render scene, this is where we want to be looking for. Oh, hey, look, there's a little 2D there, huh? You think that might be applicable? Probably. So this distance to next, we see that we see this kind of loops, and there's no real break here. Oh, there is a break here for slice rendering. So if we get rid of the slice render, everything is going to probably turn black on us, right? So let's get rid of the slice render and save that. And this might be a little bit disheartening because we're about to see nothing, I believe. Okay, so now we see nothing. So let's try to fix that now. And think about, what do we want to do with our lives? How are we going to fix this stuff? The first thought is we're just going up to max steps and kind of quitting from there. And somewhere along these lines, we had something called like color 4D. Yeah, this color 4D. Where is that declared? Okay, it's declared right up here at the top, and it's white, which makes sense. And that's why we're seeing this color here. So if we change this to, say, orange color, so let's say orange. If we change that to orange, I'm going to expect, once again, to see some orange. Okay, so we know what color we're looking at, and it's the color 4D. So color 4D, we need to start editing and figure out how are we gonna populate that with a color that is sampled from our ray marching loop. So with our ray marching loop, we have this XYZ point. And with that XYZ point, we kind of use it to sample what the voxel is, right? And so what we're going to do is, so first of all, this should be aligned here like that, right? Because we're using these variables. The voxel value, if the voxel value is non-zero, if it's greater than 0, then we actually want to, for now, we don't even want to do any marching into it. We're going to say, we really need a way to, like, render the voxel. So let's just say, we're going to forget about transparency. Let's say that like one voxel has gaps in it, so that when you're doing your ray tracing or your signed distance field ray tracing, whatever you want to call it, that you could potentially hit a voxel, and it ends up having some gaps in it, right? Because it has the details in it have like little holes in it or whatnot. So you could hit a voxel and then like ray march inside that voxel and then ray march past that voxel. That could happen. But for now, what we're going to do is we're just going to say something like you know, we could keep that loop, I guess. So this is still kind of ugly as hell, but let's just keep these here, and we'll just say that we'll call it like SDF march into voxel. And for march into voxel, we should probably give it like I don't know what we should give it. We should give it some stuff, right? And we should probably give it the voxel, and we should probably give it these like XYZ and whatever coordinates, right? And right now, this is if the voxel value is greater than 0. So all we're going to do, really, is we're just going to say, like, march into voxel, vox 0, 0, 0, and then we use the normal, and then the, like, if we look here, we use the world coordinate and then the normal, so we're calling it XYZ in this case. So we'll do XYZ, and we'll use ray world normal like that. So march into voxel, and then, we'll just say, like, hit mask. So eventually we might want some type of, like, interesting information for what we're doing. So for now, if hit mask is just a, if it's just, like, if it's just a, as long as it's a 1 or a if it's a non-zero value, we're just going to break out of here. And later we might do something more interesting where we can, like, blend together voxels, different voxel colors. If we have, like, transparent voxels and another voxel can be seen from behind, we can maybe use this hit mask to get something for that. And let's just say, like, over here, let's just say we'll call it uint or U32 hit mask. Okay, and then over here, hit mask, march into voxel, and then up above we will. So in render scene is a first degree function. So march into voxel is a second degree function. So you see how we have the second degree thing here. We actually need the function down here somewhere just because it's a second degree function. So march into voxel. Okay. Yeah, I'm just going to return a uint32. So u32 SDF march into voxel, which is going to take 3 parameters. It's going to take vox 000, and we're going to call it vox 000. And it's also going to take a a vec3. It's going to take a, I don't know if I want to, it's going to take a vec3, and that vec3 is going to be called xyz. And then it's also going to take another vec3 that is the normal, so we're going to call it the world normal, so ray world normal, right? We're going to keep the consistent naming. And close that off. And the next thing is we want to make sure, is this function actually in the correct place? Did we order everything perfectly, correctly? If we look down here where everything else is called, i32 mod is actually called i32 mod seems to be called after this SDF march into voxel, right? And because of that, I'm going to say that that the march into voxel, that this function should actually exist to have like a very strict ordering of where everything belongs. I think it should be above this integer modulo, right? So first voxel query needed. So we're going to put it there. And for SDF march into voxel, we're just going to if we need more information for like what is the color of the voxel, we could probably return it there. Or I don't know what we want to do. Well, let's just keep it as simple as possible for now. So return 1. So if we so right now we'll just return 1 for SDF march into voxel. And that'll mean the hit mask is equal to 1. And if hit mask is greater than or equal to 1, or U32 1, then we're gonna break out of this loop, right? But before we break out, we're gonna calculate whatever the color was. So that's why I think maybe we need something more than this. So you know what I'm going to do? I'm going to say that vom So I'm going to call it, I think I'll call it Voxmar for Voxel March, and then Voxel March will be assigned to March into Voxel, and then Voxel March will have like a exit, and if exit is greater than or equal to this, then we're going to break out of here. But then we'll also just say that SDF or color 4D equals a vec4. Instead of this orange, we'll say green. So it'll be like red, green, blue, and alpha 1.0. Let's just do that. That's a little bit confusing, but green. And so for this voxel march object, let's go over to the SDF march into voxel, though. And so it's going to return a vox march object. and voxmar dot exit equals 1, or equals u32 1, and then we'll just return voxmar. Okay, so now that we have this struct here that we can use, let's go back up to where we're kind of declaring all of our structs. So we have vox000, which is for something completely different, and I'm noticing that... Oh, I see, okay. So I think I had questions about how I should indent this, so let's change that up. And then let's, down here, since this is the next struct that's going to be used, we'll do voxmar. And this is the voxel marching. So this is when we're inside of the voxel, how do we handle the data that we need for voxel marching. So voxmar. And in here, we'll say that, you know, struct voxmar, and then uint and this is we could make a little note here. C hashtag voxmar about. Alright, let's just leave a little hashtag, and let's just go down into our documentation and just put what the hell this is down here, right? So just have a little details section and tell us, like, oh, what is this about, right? Holds information about okay, so that's good enough. That's kind of what I want to know about voxmar. And maybe we want to indent it like this and say like voxmar voxel march. Okay. And okay, sure, that looks good to me. Get rid of some of that extra space, go back up to where we are declaring voxmar as a struct, and say, yeah, that looks good. That's all we need right now. You know, nothing fancy. And right now, when we SDF march into voxel using these values, we're not really doing anything with them. We're just like, oh, all right, we're ready. Let's get out of here, right? So what we could do is we could return, like, we could have, like, a color value, maybe, that we want to return. That could help us with, like, maybe it's, like, the computed color for ray marching into this specific voxel. So voxmar. Yeah, so I think that'll be good right now. This guard here... So, greater than 0. Yeah, let's just give that a shot and just hope that we get something. Because I am kind of nervous here that, you know, we've done all this work and, like, my models of things are just not going to work out. But we gotta, if we're gonna make any progress, right, we gotta run it, figure it out. U32, so I'm gonna guess that U32 doesn't have a type def, so we have int32, but do we have, I feel like I've used an unsigned int before, but have I used that type def anywhere? So when I'm looking for U32, I only see it in 2 places. So let's just put that define as a top level define, and uint, right? And we don't want to get too crazy with our top level macros, right? Because I mean I can get really crazy with my top level macros in terms of like doing all this like weird stuff. Like I could have like a macro that is like, this is the prefix for functions, this is the prefix for variables. Well, I can get really crazy. You want to see how crazy I can get? Hold on. Edit dasu or dasu edit. I know it's called that. Let me look in my shortcuts really quick. So F dasu. It was called something like that. Maybe dasu. There's a whole like library I was using, so it's like some old C code I was writing. So let's see. Dasu. Oh wait, go backwards direction. So this dasu.h. Let's do h dasu.h. Let's try to find that. See if we can find something that's actually opening it, or I'm gonna be like fucking kidding me right here. So you're telling me I have all these shortcuts that are referencing a library I worked in, and I don't have a shortcut that actually opens it? That's what it's looking like. Let's just put a breakpoint at one of these things. Make sure we're not wrapping around. Nope. 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 That looks like something I already seen. Uh-huh. Nope. 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 Okay, so we have wrapped all the way around, and that's like, what the hell? I can't believe I would do something like that. So, let's go. I'm going to open up my stuff, and we're going to look for that. So I believe that would probably be... That sounds like some project that was probably in my Vulkan drive. And, yeah, so Dasu right there. So, let's see. Do we have, like, Dasu folder? Okay, so we do have that. Edit dasu h. Dasu h edit. Dasu dot h edit. Edit dasu dot h. So I do see my source code for this. So let's open this up. So language. Okay. So we'll take that. I'm just gonna paste that there. Edit file. V is for Vulkan. So in here, like if we look at how I did this code, for declarations, to do macro type aliases top, include functions.top, functions.bottom. So all these top and bottom files are likely like, so if we go into, so here's an example of how I can get a little bit crazy with macros, but I know I had some other code that was even crazier. Let's look around this a little bit more, because this might be the stuff. I just might not. So in library, oh boy, this is just. So everything is kind of segmented in way too many pieces, right? Everything's like all over the place. I can't find what I'm looking for because it's like everything is like all over the place. I don't remember what the B and D, free, kill, and terminate. Yeah, I tried to like have this very rigid structure that just had way too much granularity to it when I tried this, and it was a bad idea. Let's look at. Anyways, let's look at this. Data functions. Let's look at the functions. Okay. Nope, not what I expected. Let's look at logic macros, macro type aliases top. Let's see what we got there. Yep. So that's a little bit heavy, right? So we got all these little types. Right. So we have. So the idea here was I was trying to give everything like a really long name, and then to keep the code really terse, I was like, well, let's just give them all macros. So that's crazy. So I'm going to try to make some example references for kind of the crazy, ridiculous stuff I was doing. Type aliases, that's what we just looked at. Logic macros, top. Full file path to clipboard, right? So this is ridiculous, right? Like, I can't remember what I meant for all these different macros. So you want to keep your macro nonsense. You want to limit that kind of macro nonsense. You get carried away because you're like, it's nice that I can just create these aliases for things, but then you add more mental indirection. So what is this? So more, full file path to clipboard. Let's add that to my macro nonsense. Macro nonsense 03. I think there was something I worked on more recently, though. So let me cancel. Let's take this. And I thought there was more nonsense somewhere around here. Like, I have something like was really, really extreme, but it wasn't that, I guess. It was if we look at our V drive, maybe we can jog our memory here. So I do remember, I don't think I went that crazy on my GL easy bindings, did I? I don't think I did. Maybe I did. Nope, that's more normal. Let's sort by date modified, and ooh, maybe. Maybe not. Was it in Vulkan Glob? Did I like do something weird in here? Macros, main loop, native, OpenCL, chain file, undef. I don't think so. Oh, this says this, yeah, this probably this. Yep, bam. Okay, so this is me going way out of control with macros. So like, so all these are different ways to like, okay, I want to declare something that's some type of member, and it's private. Okay, I'll use this. Oh, it's a member and it's public. Okay, I'll use this. Okay, EII stood for existence is initialization, kind of like a take on Ray since this is C code, we can't really do array, so I came up with my own kind of bullshit thing for that. Right, argument is for argument, private, return argument, usually like a, no, return is returning from a function, right? Then BRA, don't even remember. Sub, probably like a sub member of a nested sub member of a struct, right? Like something that's deeply nested. Object is an object, like a value type. POI is a pointer. Nil is just a null. Size for when you do size of. Number of whatever, an array. Index variable. Okay, we'll just call the index variables dex, right? And so all these things. And the idea was that if we wrapped everything in one of these, then we could easily just double click and we could easily see things by category. And then also if we had a dex of something and then we had array something, we could have array of pixels and then we could have dex pixels, right? And then it would be very easy to spot where things were identical. However, in practice, I think this just ends up getting way too much abstraction, too complicated. This was overkill. So this guy over here, right, and then you have to maintain this because like I cut and I pasted this and put it like in all my different files. And then you try to like get like a self-contained piece of code. You try to cut and paste it somewhere, but oh no, it needs this huge macro header, and good luck if you used any of these things in some code. So that's just a bad idea. So I'm going to take that and I'm going to call that one macro nonsense 1, because that one is actually the most nonsensical, and we're going to do edit file. So 1, 2, 3, 4, and then we'll also call it macnon. So we want a shorter name for macro nonsense, so we know how to. So we don't have much to type when we want to like find that next time. And macro nonsense macnon. I can carried away with macros. Right? And then we'll just say that pick macnon dash 01 or 02 or 03 or 04, right? Okay, so also, do we have anything for the keyword macros? Because this would be a good time to like archive that. So we do have something from something really old. So let's take this and look for where that is. Macro. Or macro nonsense, right? So I'm just going to add that in there. And then over here, I'm going to put that right there. So macro nonsense. So macro nonsense. So next time, if I want to find these examples of weird-ass macros, if I just type the word macros, it will eventually lead me back here if I'm trying to find it. Also, maybe if somebody types nonsense, nonsense, pick nonsense kanji or macro nonsense, right? And then we'll go look for the nonsense kanji. Nonsense, and we'll take that, we'll extract that, and we'll just nonsense kanji, nonsense nonsense con k, and then we'll take this, let's get rid of that non-dash sense, and we'll put it up there. So okay. And then also we want to take the same phrasing and we want to use underscores. We'll also make a date. So now this is just me maintaining stuff instead of actually writing code. But this is how I meticulously keep track of things, so that as I'm developing, if I'm like, hey, what's that piece of code that I wrote like 5 years ago and I can't remember what it's called? Oh god, I'm never going to be able to find it anymore because it's lost. Well, no, I'll be able to find it. I'll be able to find it. Trust me. So, inserted date and 2020 11/27, right? Just keeping a record of everything I've touched since the beginning of time. Well, not really since the beginning of like 3 years ago I started doing this. Is it a good idea? Is what I'm doing a good idea? Yeah, I don't know, man. You know, it's a long running experiment, and we'll see if it seems like it might be valuable. It seems like it kind of helps. Though the downside is, man, that it slows you down, right? So the idea is to have, I'm kind of like going for a strategy of I code really slow, but I have like a lot of torque, you know? What's kind of the goal? And maybe it's wrong. Maybe I'm batshit crazy and what I'm doing is a stupid idea and I should just stop. Okay, so anyways, we put that U32 in there, but we also have to remember to undefine it. So we could actually copy all this stuff, go back down here, and we could just, you know, paste that, and then just 1, 2, 3, 4, 5, 6. So there was only one unaccounted for, but by doing that, we can kind of reevaluate that section and make sure that it's still up to date. And then we'll just undef. So undef them all, and let's give this a run now that we've kind of been sidetracked by like running through the code that I've written previously. Okay, so I don't know what I'm looking at, but I tell you what, I feel like this is progress. This is fucking progress. Yeah, it's progress. It's not a... Let's dolly that, right? Let's add a dolly and see kind of what we can see. So I can see that, it looks like we're kind of making the outline of the... Because I know the camera is positioned right on, the, on the top of the voxel bounding volume. That's pretty cool. It's not... It's very odd that there's a strobing, because you would kind of assume that... Although those must be air pixels, because the air pixels strobe. Hey, yeah, let's just dolly this. Let's just go look at the dolly code and just add some dolly and see what happens, you know? You know, let's try to not be super depressed about this shitstorm of stuff. Let's just try to have some fun, relax, and be like, hey, observe, and maybe, oh god, oh god, oh god! Uh-huh. That's kind of fun. So I think what's going wrong here is that I'm not ray marching. Yeah, cause it's not, yeah, cause I don't think I'm properly ray marching. I think I'm still using, I still think I'm slice planing through stuff. You know what? I'm gonna stop here because yeah, I think I'll stop here. You know why? Because we've got something that it kind of looks pretty cool. It obviously needs to be fixed, but it's like it's a good like checkpoint to where like we can save this as our SDF11 file, and then we kind of have like a nice something that's very visually unique for this checkpoint, and we can kind of we can what's the word? I don't know. It's good. Like if I were to make like say a gallery of all of these little podcast thingies that I've been working on, it'd be nice for every thumbnail to be unique, right? For every like little demo of what I'm working on to be unique, so that you can see like the progress from day to day by just looking at the thumbnails. So this looks like progress to me. It's it's weird. So yeah, that's what we're gonna do, and then we can kind of think about what's actually going on here. I think that it's that we're actually using it as a slice plane, so we can look at the code still. We could do like we can still look at the code and kind of analyze what might be happening. So slice render is no longer happening. And if slice render, we break out of here. And okay, yeah, so here's a problem. I wanted to originally like stop, but if we look at this, this break gets out of this voxel this voxel marching, but it doesn't break out of this voxel loop, right? So we've marched, we've hit a voxel, and here we've hit a voxel, and we do some ray marching inside that voxel, and then we break out of the interior of the voxel ray march, but we never break out of this exterior. So that would be a reason for... God damn it, what the hell did I change? So this little red is up there. That's no good. So let's... Oh, we changed the dolly. Yeah, okay. So let's save that. Let's run that. Let's rerun it. Just make sure that we're where we think we're supposed to be. Okay, yeah. So let's take this and let's update some of our URLs. So our paste bin. I'm gonna edit the paste bin, and I'm gonna just put this new code into there. And syntax highlighting, we're gonna do GL. I don't know why they don't have a GLSL. They just have OpenGL shading. It's like, whatever. Okay, so save those changes. Okay, cool. So now, if I were to take the direct demo, let's close. So let's open up a new tab. Let's close this. I'm gonna leave, and we're gonna just. Ooh, you know what? I think I might have to hit the save button for that. So let's go here to my shader. And okay, yeah. So we still have the old code. So what we want to do is we want to take this code, and we want to take it all, and we want to paste it in there, and we want to compile it, and then after that we want to save it. Oh, so I'm not signed in, so leave. Okay, and we'll do... Okay, let's sign in. And let's look at, I think if we go here, so SDF 11 is the one we were working on, so we're going to take this one. We're going to open that up, and then we're going to take all the code we've done, and we're going to paste it in here. We're going to run it, make sure we have what we're expecting, and then we're going to hit the save button. Okay, now that we've hit save, let's try leaving. We're going to open up a new tab, and we're going to make sure that when we try to go to the URL for the for tinyurl.com SDF11 demo, I want to get back to that shader. So I'm gonna put that in the into my browser, and it's taking me back. Oh, and there we go. We got this orange and green kind of crazy stuff, and oh god, let's try to eventually fix this. But that's cool because we have some type of feedback. We have something with structure. We got something interesting, right? It's still broken as hell, but it's like it's coming along, and we got some interesting results that are like, well, at the end of the day, we don't got any voxels, but we sure got something interesting, you know? So that's good. Now, the other thing is, I know we had something about zoom. So if I go Control F and I look for zoom, zoomed in camera. Okay, cool. So I have zoomed in camera, and we have a 1. So if I change that zoomed in camera to 0, I'm hoping that it'll be zoomed out and we'll have a little bit finer detail, and we might see something kind of interesting. So let's give that a shot and see what happens. That's kind of cool. So we can kind of tell that there's like this voxel volume. I can kind of see it. I can kind of see the geometry I built by zooming out. Like, I can see it. It's kind of like hard to tell, but it's like there. So it looks like to me that we're definitely hitting all that geometry, but we're kind of slicing in and out of the entire voxel volume. That's really fun though. That's like really cool. Like I like how that looks. However, before we continue, I think it's good to start a new video just because we have this very cool kind of checkpoint where we have this kind of like interesting effect, and we can like observe what's actually going on there. But I would say we're really close to getting those voxels to render, and then once we get the voxels to render, we got to figure out how we're going to we have to figure out how we're going to get like tune shader edges around these voxels, but we're getting close here. So it's like it's yeah, so we got something that I'm kind of like happy with. Well, not completely happy with, but so it looks like the camera I think what's happening is the camera is only getting like 1 ray march. I don't know. But we did already see problems in the code that were very obvious. So we can fix those problems, and then we can also try to figure out what the other problems are with this code. But let's stop there for now. And because we're gonna I'm gonna copy all the code. I'm gonna make another file called like SDF12, and we're going to kind of make another shot at this and just keep on going, and hopefully we're gonna get something good. And eventually, I'm gonna have some rendering software for the pattern drawings I've been working on. Yes, that's what I'm doing this for, because can't find. There used to be this thing called SketchUp that worked great, and that like costs like license or money or some bullshit, and so I'm gonna try to redraw some of the patents that I've been working on in just pure shader code using like a shader rendering engine to create drawings that are acceptable for the United States Patent and Trademark Office. So they have very specific criteria for how they want their drawings to be done, and so I'm going to try to create a renderer that will render patent drawings in the style that is needed. So I want something that does orthographic and also isometric perspective. So I want everything just to be really what do you call it? To get a camera at exactly an isometric perspective seems to be a thing that is not trivial. Software with isometric rendering. We could probably look that up. So while we're at it, so it looks like there's isometric sketching and rendering. Okay, so I'm going to go do some research and see what I can find, but I'm done recording here for now, so later.